we were trying to figure out how we're going to measure the time.
Well, which one are you supposed to be changing, time or temperature? Okay, so how can you change time? Yeah, because you don't actually have to do anything to change time. Time changes by itself, right? We're already a minute past where we were a minute ago. So changing the time is easy. You just let whatever you're doing run for that time. And that's changing the time.
So like, if we were boiling something, we'd have a certain time.
So like for some jobs, it'd be like you can see the process and be like you leave it there for.
So that's one way you could do it, but it's gonna be harder to do that because you're gonna keep restarting over and over.
Do you just take the temperature at different points?
Right, as you go, you can just keep taking the temperature because what you said, like, it's not going to be any different, probably really much different between 1 and 2 minutes. So if you do from 0 to 2, and then you do from 0 to 4, it's not going to be, that first part is still going to be the same. So if you just let it run, you can just keep taking the temperature, and then that can show you where you're at. That's changing the time and measuring the temperature. So come up with some more exactly what you're going to do, so that gives you an idea.
Should we like heat up some? And are we gonna be heating up water or an ice cube? Yeah, we'll let them know.
But I don't get that. It says on the graph you must label what state of water or matter were occurring at each location.
So right now we only have two locations. We only have the frozen, which is solid, and we have the liquid. We still need the gas one. So maybe we need to change the 75 back up to boiling point,
Which one went
so that we can label it on the graph as a gas.
what the initial
Right?
temperature was, what the final temperature
So
was.
let's do
But what I think it means by like on the graph, like when it says it'd be like one big graph and it'd be one line.
yeah. That's
And so it'd be like in some areas it'd be like it'd be solid, like it's solid and then like liquid. This way it's liquid, and then it changes to gas.
Yeah, that's why I figured. That's why. So we need to change the 75 as our high sheet back up to maybe 100 or so that we can label that on the graph. Because otherwise 75 is still a liquid.
Yeah. So but then again, at 75 it would also give off a little bit of vapor. Very little, since it's already heating up. So let's change it to 100.
Yeah, let's do about 100.
Oh, okay.
Well, yeah, that's about it.
Are we gonna go?
I think
That's basically
Put ice in the
this would be for what?
I think we're doing we should do temperature. I think we were just like make time like at what certain time do we like
Yes. Use the hot plate. What temperature? What temperature should we do? 500? 500?
Is it Celsius or Fahrenheit? I forget.
It's Fahrenheit.
Oh, it's Fahrenheit.
Yeah.
Oh, okay. Are you sure we want to do 500?
I think
so we can set it down.
What do you guys think?
What do you mean?
Because are we gonna take the 500 and we're just water out instead of and then leaving the thermometer in there? Checking everything.
Oh no, we were putting the water on it, keeping the thermometer in there and checking every minute as it heats up, not as the heat goes down.
Oh, okay. So we're starting at room temperature?
Yeah, we're starting at room temperature, and then we have a different variable is the heat of the hot plate. What heat should we use? Wanna do 300 degrees?
300 sounds good.
Okay. So we do 300 degrees with the hot plate, then we have a thermometer, and we check room temperature, whatever that is.
It's probably 27 degrees Celsius. So it's in shrooms degrees.
So we check that, we set it on the hot plate, we make sure the hot plate is 300 degrees. Then we check periodically every 60 seconds, resulting in our 10 different results, because we're going for 10 minutes. And then we graph temperature versus time, see what the pattern is.
See how the changing time affects the temperature.
Increase the temperature?
You want to see how the changing time affects the temperature.
Yeah.
Temperature.
You must graph temperature versus time.
Well, if you're going from a solid to a liquid, the more time you give it, the more it'll turn into a liquid, right?
But that's not about the phase change, but what are we supposed to
See
measure?
how much water has evaporated.
What do we want to record?
Temperature.
Temperature.
So when we check temperature,
Keep
we
talking.
check
So you guys can come up with
so write that down.
it.
So check every 60 seconds.
You're just finding this and you want to see how temperature, how change in time affects the temperature.
Temperature and amount. Okay.
So keep talking and see if you guys can come up with something. Alright, where are we at now?
Well, we came up with a.
It's like saying, oh, we'll do it 10 minutes. Is that gonna make it hotter? So I don't really get it.
Place it on
Same thing.
30 degrees.
Would it be like
Check
you
it
leave it there
every
and then
minute,
like
temperature
leave
and
the
how much
thermometer
water
in
is
it,
left.
and then we just come back and like see what the
For 10
temperature is?
minutes, and then we're gonna see how much temperature has risen and how much water is.
How often, you said you're going to record the temperature every so often?
Yeah, every minute.
A couple things on that one, don't restrict it to just 10 minutes because you want to make sure you're past boiling for, probably be boiling for like maybe 5 minutes and then you can stop it. Just to see if you're boiling for the and there was something else. What were, tell me your procedures again.
Well, we're going to have 100 milliliters of water. We're going to heat it on a hot plate. We're going to check every 60 seconds to see the change in temperature.
Let me stop you there already. So you're starting from water?
Because it was melting.
It says phase change. Did you guys talk about any data yet?
3, 17.
Is there any more solid in there? 330.
Yeah, we got a little bit.
Did you guys talk about the data at all yet? While you were
Well, it went down, or it went up, then it went down, then it went up again. So we talked about that, did we?
Yeah.
What did you talk about?
I feel like because it was on the ice for such a long time, it was like down as well.
So liquid was still being cooled.
We're going
19.
to talk about it more next time.
What was it?
19,000.
For solid still?
Yup, we got a little bit. I kind of want to lick it. I'm talking about the hot plate, not the. No.
Yeah, I like the little lines.
Was it that? It's just stuck pretty much at 80. Like it's not going any higher. Wait, start.
It's going up. It's going back down.
So then 80 was its max? It can't be. 80 cannot be the max. It's not even boiling point yet. So that keeps going down. So what, at 7:30 it was what? It was at 80, huh?
It was at 80.
And what, now it's like a 79?
Yeah. No, wait. Yeah, it's 79.
That's definitely not normal.
She said something like 35 minutes. Boiling point. So until it
It dropped. Is it still dropping?
It's going to be 30 seconds right now. What is it?
It's back. It's 79. Wait.
10 seconds.
78.
It's at 32 and it's been at 32.
28.5.
So now my guess is it's gonna 5:30.
That's another variable. Alright, 50. Or percent.
They went from 20 to 60 to 50 to 40.
81 so. It's like right away.
Going from 81 to 79 to 78 to 79 to 81.
Okay, ready to go?
Well, now we're getting a weird measurement.
Going down again? One possible source of air is the possibility.
Just tangent, something's wrong with your room.
Oh, yeah.
Your temperature keeps fluctuating at unnatural rates.
So we need to wait until the ice.
Now it's going
Get the
down.
little piece together.
Way to go from like fluctuating to down.
So at the next variable, it's at 49.
Because what did you expect to happen?
It to just continue until it boils.
But no, it's only, it's not even halfway there, and it's going down.
To 14.
Right, 5 seconds. 81. And it's
We're not even there yet.
14.
So we're like at 40.
14.
14.
14.
So Curtis is in front of
Until it boils.
No, this.
Until it goes low to what we're doing.
So when do we set this on?
When
you guys been getting some funky answers?
Yeah.
Cause I'm mad.
What do you find funky about it?
The fact that one would have expected and assumed that it's gonna go up, but it's actually on down.
Yeah, it's going up and down.
It's like
How much is it changing by?
1 or 2.
49.
If it's only changing by 1 or 2, that's pretty much the same amount, right? So it's basically saying the same temperature for all that. So maybe think about why it's staying the same temperature. Yuli, did you hear that? It's not changing by that much, right?
And it's
Pretty
80.
much the sign that it's saying the same. Like when you grab that, those are gonna be all phased.
What was it at 10:30 though?
So you guys can talk about
10:30
why
was
it's
81
the
degrees
same.
Celsius. Straight.
Okay.
Because think about it, because I think it's because the ice is still melting, so it's still holding on to that coldness. So it's like,
And then it's like, what's going on is this is trying to melt the ice, and while it's after melts the ice, it still has a cold in there.
Yeah.
But then after being cold, it needs to get to room temperature, and then it needs to boil. So that's what happened. It just needed a it just needed to change phase first to then change the temperature.
yeah.
8:30.
8:30.
Now that you have your data in front of you, what you think is happening where and why it created that shape of a graph. Talk at your table.
So what was the theory that we
Okay, so
in order to change temperature, it needs to change phase,
Well,
right?
added
So based off of the graph, we can all
lower degrees.
agree
And
that
then once it started temperatures,
when it was a solid, it was one temperature, and then when it started to slowly change into water,
started turning into a
because
gas.
we were boiling it, it started to change into a different temperature. However, it
Well,
would
it was
increase and
between
then
the gas
decrease and
and
then increase.
it was still between liquid and
It was
gas.
still,
But it was on its way
consistent,
to turn
but
into
it was
gas.
increasing and
And then at
decreasing.
the final time, it was like completely gas.
Yeah, that's completely evaporated.
You guys have anything else?
What else? It's just, it was an average. It was average.
What else?
But mine was out of 25 minutes.
The AC, yeah.
Out of
So
25?
air conditioning.
Yeah.
So when exactly did you
Oh, just the way the chart was.
It just set it up like that, like.
The way I did it was I put 30 seconds
So,
and then 30 seconds of
basically
continuous
it.
graph that it came up with. I was going to do
I wasn't sure if we were supposed to do that.
Yeah, that's why, because when the thermometer was laying on the ice,
Yeah.
like it was resting on the ice, so it wasn't very low.
Right.
But once it got through the water that was on the hot plate, then it was gonna go high. So I was at dips.
Yeah. Also,
Like right here, like I don't understand why.
well, we were constant for a bit, for at least, I don't know, like 4 or 5 minutes, and then it started going down. That means we couldn't get any hotter. So, what does that mean?
Oh, we can't get colder either.
No, we did. We got colder,
I know, but that's
but this was our peak. We couldn't go any higher than that.
so maybe because of the thermometer, because it was cold.
Maybe, I don't know. What do you think?
I don't know, like I don't see how it would get from hot to cold when it was at its highest point. Like it dips like certain parts of the water that's hot and cold. Like if the heat wasn't distributed earlier, so the thermometer might have moved to a colder area.
Yeah. But it's just really weird how we get to the top. We expected it to get boiling,
Automatically read
which
it.
it never did.
Alright, I heard a lot of really good discussion. So what did you guys come up with? Share with me some of what you thought. Nice.
The more, like, the longer we wait in minutes, our lab showed that the temperature would increase,
Okay.
so the heat would increase the longer you leave it on the hot plate.
Did it always increase everywhere?
No, we would have dips in our graphs.
Okay. Did you guys come up with an idea of why you thought the dips were happening? What did you
Because we had our thermometer laid on the ice cube, so while the rest of the ice cube was melting, it was already touching the heat plate. So the water was already heated, but when the ice melted to the point where the thermometer got through the ice cube, it would touch the hot part, so it would go in the change of temperature.
Okay, that's a good idea. How can you tell if it was something like that were a source of error, or whether it's just perfectly doing that?
I guess observing the lab, making sure that you're precise and
How do you tell if you were precise?
holding the thermometer probably, or
Okay, any other ideas of how you would tell if you were precise?
Repeating the process.
Repeating it. So how many times did we do the lab in here?
Once.
Well, but 5 groups, right? Does everybody have a graph that kind of looks like this?
no.
Where it like increases and then flattens out and then increases again? Yeah. You all have this. So do you think it was solely due to experimental error if we all got the same thing? I same a general idea. So, I know I heard in the lab, your group back there, you guys had an idea of what was happening in each region, right? You want to share with everybody?
We agreed that in order for the temperature to change, the phase needed to change because it did start as a solid and then it ended up as a liquid. And we noticed that once it got to its boiling point, the water wouldn't get hotter, it would just either stay consistent or drop a little, but that's what.
Okay, so instead of going towards changing the temperature of the solution, what was the heat going towards? Like when it was staying flat, instead of changing the temperature of the solution, you were still adding heat from the hot plate. What was that doing instead of changing the temperature?
The phase.
Right, that was going towards changing the phase. So I want you to mark on your graphs as we kind of go over this, so that's why you had it printed out. So this one would be with the perfect conditions right here. Do you think that you can have ice that's less than 0 degrees?
Yes.
Yes, some people think you can't. They think, oh, ice, 0 degrees. But that's just when it starts to freeze, right? But you can still have ice colder than that. So if you took ice and you were at, what temperature is that about?
32.
Right here?
Oh.
Yeah, like -7, -8 or so. What state or states of matter do you think is in this first segment of the graph? Solid. That's when you're just ice. What state or states of matter is in this region of the graph? This flat region right here. Solid and liquid, because it's going through a phase change. So instead of going to changing the temperature, the heat you're adding is going towards changing the phase. What do you think is happening in this region? What kind of state? Yep, liquid, this one?
Gas.
Liquid and gas. And what would you predict would happen if we were able to take the temperature of the gas? Because how you designed it, you didn't really have a way to take the temperature of the gas. But maybe if you had it in a closed container, you could have still kept finding the temperature of the gas. What do you think would happen once it's all done converting into gas? Why? If you're still adding heat to the system. So when we had a solid, it was just a solid, and then it flattened out, and then we had just a liquid, and then it flattened out. Talk to your tables and see if you guys can figure out what would happen if you were still increasing the heat and it was all gas. Talk to people next to you.
They just heat up, right? They keep heating.
If it's in a closed container, one would want to expand though. So one would stay condensed.
If we stop heating it, then
The gas will clear in water, right?
Wouldn't it be like a steam acting? Because I mean, there's only so much that you can cook with it. Yeah.
because we're gonna keep heating.
From the very beginning towards the end, the gas there.
Like it wouldn't like lose any volume of water.
Because it would also be transmitted
Inside, yeah.
Alright, Austin, what did your group come up with?
We said that if we increase the temperature, it pretty much just increase the speed. Or wait, that's backwards.
What would the graph look like if you continue to increase the temperature but all you have is gas?
Wouldn't it just increase?
It would keep increasing.
Does everybody, any other ideas? Does everybody else think that too? What do you think?
I think wouldn't it just drop down to room temperature?
But-
Because like you're saying that the liquid's gonna turn into gas because you're heating it up, so eventually that liquid's gonna be gas completely. And how are you gonna measure the temperature of gas if it's just gonna?
We were saying if we could, like if we had that gas contained in the container,
Oh, okay.
how would
Okay,
we?
yeah.
What would the graph look like?
It would increase.
Right, it'd be the same way you would extend it from right here, and it would just increase right there. And what state or states of matter would there be in that region? Just gas. So you need to know this order that you have just solid and then solid and liquid and